Hey, and welcome back to another Learning Java 2D Game Programming video. So, in our last video, which was quite long, we got a lot of stuff done though. We managed to start blowing bubbles. So what we do now is that we blow soap bubbles around our humanoids, and when they're inside this bubble, they are floating around. They cannot spread disease. So currently they can't cough even if they wanted to, but the point is if they're inside the bubble, they're not supposed to be able to infect anyone else anyway, so they're isolated. So for today, we are going to be able to make them just float off screen, and we'll also make sure to update this score here. So right now it doesn't care whether they're isolated or not. It will just tick up. So I guess let's get to that. Also, I forgot to show you something. So if you enter debug mode, you can see that this collision box isn't offset properly. So we copied the humanoid's offset when we parent it to this bubble, but we don't do that for the collision box. So we can just quickly fix that, and it doesn't really matter because we're not doing anything with the collision, but just for the sake of it. So let's just find the bubble first. If you go here and say this dot collision box offset, let's actually just set it to the render offset that you just set. So now they are pointing at the same offset. So if you do this again, you'll see it looks better. All right. But now that we are inside of this class, let me just check. So I sort of changed my mind a little about using this controller. I don't think we have to use this controller at all. I mean, it depends on what we want to do, but we're going to keep it simple. So we're not going to do that. We're not even going to update it using the controller. Instead, we're going to say motion, and we're going to add an add method. So we're going to be able to add a vector in here. So for now, just say a new vector 2D, and let's say that this bubble is going to soar upwards always. So nowhere in the x-axis, but some value in the y-axis. I'm going to say 0.5. So it will travel upwards with 0.5 pixels per update, I guess. So that's where that is, and we're going to have to add that to the motion. So create the add in the motion. Let's just rename this to vector. And funnily enough, now we need to grab this vector, so this member vector. And to that, we want to add the vector that we pass in. And we have to generate this method as well. So now it's just x plus equals vector get x and y plus equals vector get y. All right, we can close those two off. So now we can just add a vector to our motion. So that makes it a little easier for us. All right, I wonder if there's anything else. Yeah. Actually, because what'll happen now if we try this out, let's just let it think a little bit. If we try this out, ooh, look at that. See what happened now? It says the y plus height is outside the raster. This happened because we added some motion to it. Oops, sorry. And if you go inside and look in the moving entity, let's see, manage direction. Here we go. Why can't I click it? There we are. So if we're moving, which we are getting the direction from the motion, and eventually we are asking the direction for the animation row. And this is what we're using when we're finding, if we take a look in our sprites, so our bubble is in one row, while our units have this. So these are, of course, the different animation rows, directions, you know that. you've been here for it. But we don't have that in the bubble. So the bubble is always at animation row 0. So there is a way that we can do that. So after we say motion.add, let's just say direction is equal to direction.s. So it's always direction.s, right? And there we go. But now you can see another thing. So it starts soaring off as soon as we click. And maybe we want to make it stay for as long as we are blowing the bubble. And we might want to change how long that takes. So we need a way to make sure that our bubble doesn't move, that it's halted. So I'm going to put that in here for now, because right now only the bubble needs this. If we need it somewhere else, we will refactor it in the future. But right now I'm just going to say private boolean halted. And we're going to need some method of setting it to be halted. Halt. And this just says halted is equal to true. And then we say here, if we're not halted, then we're adding the motion. Also, make sure that halted always gets set to false. So this will be set back to true again by our, let's find from the humanoid to the action, blow bubble. So in this blow bubble, if bubble is null, we're bubbling the target, but if it's not null, whoop, there should be an else in there. If it's not null, halt. All right. So now our blow bubble will halt our bubble for as long as this blow bubble exists. As soon as it stops existing, our bubble will be free to move again. So there we go. Now it actually stops until the blow bubble is finished. This is probably more what we want. So I'm going to leave it at that. All right. What else? Just going to check for time. Oh, we've only used 7 minutes. So I'd like to actually do something with this. If you go into the GameState you have here, we have also this UI sickness statistics. So currently, as I said in the beginning, this just shows how many people have the sick effect. So even if we put them in bubbles, it's still gonna just say, 14. Even if all of these 14 were in a bubble, it's still gonna say 14. And we want a way to know whether we've bubbled the right ones. So what I'm gonna do is I'm actually gonna move this count thing into our state, into our game state even. So this UI sickness statistics is very specific to our game, as is the game state. It's specific to our game right now. So I'm going to move it in here. I'm going to make a public long, and it's a long because stream, the count method of the stream API returns a long. So get number of sick, right? And then we say return here. Okay. And let's copy that and do it the same for get number of healthy. So that is not affected by the sick class. Go back into your statistics and let's fix it inside here. So as I said, this class is specific to our game. So this state will probably be our game state. And if state instance of game state, then first of all, let's get the game state out of there. All right, and then we no longer need this. We can move these inside. And we don't, yes, we do need the string value up still, but what we do is game state, get number of sick, and game state, get number of healthy. All right, so just check that this still works as it should. And it does. So what we want to do now is when we're getting this, it's not just anymore if you're affected by sick, it's also if you are not isolated. So you're sick, but you're not in isolation yet, which means that you can still infect other people. But right now, we don't have anything that tells us if we're in isolation, but we do. So we made an effect that's called untargetable that we only used so that we can't target it. But this is a perfect candidate because that's the only thing that it did. And now we needed to do something more. So let's call it isolated. So when you're isolated, we still can't target you, but now it means something else. So now we can go here and say that if you're affected by sick and you're not affected by isolated.class, then you're still sick. And we can actually get the number of correctly isolated, get number of, let's just call it isolated for now, even though that's sort of a lie, because you can of course isolate healthy people, but that's not really interesting. So it's interesting if they are affected by the sick and they are also affected by isolated. Those are the really interesting ones. So we can just quickly go into here. Let's just change this entire thing. Let's say string.format. It's easier. So percentage %d means digit. And then I'm going to just put inside of parentheses. So now if you've never used string.format before, first you give it the string and then you give it stuff that it will replace. So d means a digit, which means that first we give it a digit after this comma and then we give it the next argument. So here I'd say GameState get number of sick, and then for the other percentage I would say GameState get number of isolated. So let's just try that quickly. All right, there you go. 10 people are sick and 0 of those sick people are in isolation. So it would be fun to test this out, but I'm guessing it's gonna be a little hard to find anyone. So just to make it a little easier, we're just quickly gonna go into our debug renderer. So we're just gonna do something so that we can see who is sick. So not sure how I'm gonna do it. I'm just gonna make another method. Let's call it, private void draw effect names, maybe draw effects. Let's call it draw effects for now, and it's gonna take it as states and the graphics that we're drawing to. All right, so let's just say, just like up there, let's get the camera out first, get camera, and then let's do state, get game objects of class, because only humanoids are interesting, say stream, and then I guess for each humanoid, first we're gonna have to let's make use of the UI text that we have. So let's just say effects text, new UI text, and this takes in the string that we want. And let's just make it in its own row because I think that this will be a little large. So what we're doing is humanoid get effects, and we don't have that method, so let's generate it inside of the humanoid, and this will be a list of effect. There we go, and return effects. All right, back to the debug render. So get the list of effects. So let's just say stream, and what we want to do then is map it first. We want to get the class name so that if it's a sick, it'll say sick. Otherwise, it'll just give us some weird object hash. I don't know. So let's first of all map it to the class name. So from our effect, let's get effect, get class, get simple name. And then let's collect collectors joining, and in here you can give it a delimiter. So I'm gonna just give it a comma. So they will be comma separated. Oh, sorry. All right, so this is the text that we're gonna draw. And because of the way that this is meant to be used, you actually have to update it once to make it calculate the size and, well, the size, if you remember. So let's just make it update once. Now we can draw it to our graphics like any image. So there, let's get the get sprite, and then we want to use the humanoids position. So int x, since we're dealing with pixels now, and let's subtract the camera get position int x. Then do the same for the y, humanoid get position int y minus camera get position int y. And then just null for the observer. All right, let's see. We also need to call it, of course. So draw effects with the state and the graphics. Let's see if that did the trick. If you go into the game now and press F2, there you can see it. One guy is sick over there. Let's go get him. Let's go get, he's running away. No fun, stop, thank you. Okay, we got him. So now you can see that he has sick and he has isolated. And if you look at our stats, you can also see that 18 people are sick and 1 is in isolation. And if we isolate someone who isn't sick, then that 1 stays the same. Also, it's not counted in the healthy. And eventually in the future, maybe if we have some sort of point system, we want to give a penalty for isolating healthy people. I don't know, we could do that. There are many ways we could go, but I'm gonna call this a day. So for the next video, I think we're gonna start dealing with victory and defeat conditions. But until then, thank you for watching, and I'll see you soon. Hej då!